Okay, so this video is going to be about how to solve quadratics through factorising. Um, Hopefully you can see this screen. I think I have to go back a slide for it to pop up, but hopefully you can see this thing that says what is a quadratic. So there's just a very brief recap. So what I'm going to do in this video is I'm going to do about 1 minute recap on what a quadratic is, about 5 minute recap on how to factorise quadratics, and then I'm going to go into solving. So if you think you're confident with the first two, just zoom ahead and don't waste your time hearing it all again. But if you want to, because they're the two skills we're going to need before we can start solving, then stick around. So a quadratic, this is a positive quadratic that I've drawn there. I think it's just the x squared. Yep, that's just x squared. Y equals x squared. It's an equation that's in the form of this. So ax squared plus bx plus c. A, b and c can be any number we want. If a is 0, then the x squared disappears. It's not a quadratic, so we don't want a to be 0. And x is the thing that changes all the time, which we call a variable, or an unknown is the less fancy word for it. And when we solve it, that's the thing we want to be able to find out. And it's a different skill to just solving a linear equation, so like a 2x equals 4 sort of thing. And that's what we're going to learn today. So, quick recap on factorising itself, because we're going to need to factorise to be able to solve. So if our skills of factorising aren't quite up to scratch, then it's going to be quite difficult for us. So, the quick note up here, we need to find two numbers that add together to make b, and what I mean by that is this 7 here, and multiply to make c, which is our number on the end. So what we want to do is we want to look for our factors of 12. So our factors of 12 are going to be 1 and 12, 2 and 6, 3 and 4. There's no more of them. So factors are obviously just numbers that times together to make it. Then we've got to think, well, what are these combinations of numbers going to add together to make 7? So if we had combinations of 1 and 12, well, if we did 1 add 12, we'd get 13. If we did 1 take away 12, we'd get minus 11. So that's obviously not going to work. 2s and 6s, well, they're going to make 8s and 4s, so that's not going to work. 3 and 4, that would work. So right now, I'm pretty confident in saying this is the first step of what my factorising is going to look like. We just need to fill in if this is a plus or a minus in the middle of these. Well, positive 3 times positive 4 makes positive 12. That works, and let's check if we do positive 3 plus positive 4 to get a 7, which it does. So this equals to 12, and positive 3 plus 4 equals to 7. So both of our checks have worked. You can see the two numbers that are there. And always just double check this by expanding it again, because that's the point of factorising. If you factorise it, you put it into brackets. If you expand it, you should just turn out with what we started. So another example. This one here, so we want to find my factors of 6. So my factors of 6 are going to be 1 and 6, 2 and 3. And I want to know how I'm going to make minus 5 by adding them together. Well, 1 and 6 and 2 and 3 can both seem to make 5, so this one seems to give us a few more kind of problems. But let's just trial and error a lot of these things. So to make a positive number with multiplying, we either have to do a positive times a positive or a negative times a negative. So I know both the signs in here are going to be positive, or they're both going to be negative. There's not going to be one positive and one negative. And when I add to make a minus number, well, if I add two positive numbers together, they're going to become positive. But if I add two negative numbers together, that's going to stay negative. So I know these are both negative numbers. And well, let's just trial the numbers. If I did minus 1 plus minus 6, that would get me minus 7. So minus 1 plus minus 6. Remember, when we plus a minus, it kind of overrides to just be a subtract. That gets me minus 7, which is not good. If I do minus 2 plus minus 3, well, that's the same as minus 2. subtract 3. That gives me minus 5. So that is what I want to go in my brackets. So a little bit more difficult with a negative, but if you just kind of go through the steps and don't be afraid to try some stuff, put some stuff in your brackets, expand it. If it doesn't work, put one line through it and just try again. But that would be our factorised form. There's 2 questions there for you to have a very quick check at, and I'm just going to put the answers up on the board, on the screen now, so if you just want to pause it, feel free. So our 2 answers are there. It doesn't matter which way you have your brackets round, so don't worry about that. And this is only in case you want to pause it and have a bit more practice on factorising. I'm not making you do it, this isn't part of your task. So just pause it if you want to, and they are the answers that link up for if you did have a go at any of them. Very, very quick note on these difference of 2 squares. This is where we have a square number, so x squared is a square number. Subtract another square number, 36 is a square number, 6 times 6. This is a special case because we don't have any x terms in the middle, do we? And they're actually really easy once you do them, but it's a bit more difficult to spot. So what we do is we square root the x squared, which just gives us x, and we put that at the front. And then we square root the 36, which is 6, and we put that there. And what we need to do is we need to have one positive and one negative. Because when we expand this, if we do x times x, that's x squared. X times minus 6, that's minus 6x. 6 times x, that's 6x. And 6 times minus 6, that's minus 36. Can we see how these cancel out? So minus 6 and plus 6 will cancel out to be 0, and it actually leaves us with our answer. So you just want to square root both of them and have a plus and a minus in your brackets with them 2 things either side. Have a quick go at this one and see if you can get this one right, and I will put the answer up quickly. So the answer to this one would be b plus 10, b minus 10. You could have minus 10 plus 10, it doesn't matter. And that is just square root in both of them, putting a plus and minus in your brackets. There's 4 more there if you want to have a go, but they're your 4 answers. Okay, on to actually what we were wanting to look at today. So I will timestamp this in the description or something so you can jump straight to it. But solving, so this is something we won't have seen before. We won't really have seen quadratics with an equal sign in just yet, apart from when we've been drawing them when we got y equals. Just have a quick think to yourself and think, how the hell can we solve this? Because adding and subtracting onto both sides isn't going to work, because we can't really get x's all on one side, because we've got x squareds and x's. So our first step would be to factorise. So if I factorise this one, I'm going to get x plus 3. Oh, no, I'm not. Let me cross that out. I'm going to get x plus 5, x plus 1, because 1 times 5 is 5, and 5 plus 1 is 6. And that still equals 0. All I've done is just kind of change how this left side looks. So that's my first step all the time. We want to make this side equal to 0 to be able to solve it, but it's quite difficult. You can't just trial and error some numbers in there. But if I make this bracket equal 0, let's say, well, if this is 0, 0 times by whatever is in this bracket, 0 times by anything is 0, isn't it? So if I make this bracket 0, no matter what this bracket turns into be, it doesn't matter. Because if I'm going to times it by 0, I'll make it equal to 0. And then I want to do the same with that bracket as well. So we're going to get 2 solutions here, and you'll have seen the video before this, the lesson before this, which will have gone into some details of why, and you'll have seen kind of the graphs go through the x-axis twice. So the values we get at the end of this are actually the 2 points on our graph in these locations. So yeah, we want to make each bracket equal to 0. So I'm going to make 2 equations here. I want to say, well, when is x plus 5 equal to 0? Or when is x plus 1 equal to 0? Just taken what's in these brackets and made them equal to 0. Well, this is just a very simple 1-step equation. X equals to minus 5 is our first answer, and x equals to minus 1 is my second answer. So we'll get two solutions, and you just want to write them like that. So you might just want to go out to the side and say x equals minus 5, x equals minus 1. And then if we were to plot that, we'd have a dash at minus 1, dash at minus 5, and we'd know our quadratic could go through these points. We don't know what would happen with the rest of it. We don't know where it would cross. Well, that would cross at 5 actually, because of this 5 here. But we don't know what our minimum point would be, but we could figure that out if we drew the graph accurately and looked at it. But that's kind of a way into some more high-level stuff, drawing it from the factorization form. So, if you can think to yourself before I go through these, that would be great. What would be the solution to this? So I've already factorized it for you. What would be the two solutions to this? Okay, so, well, I know it's either going to be when x plus 3 equals 0, or when x minus 2 equals 0. So this is going to be when, take 3 from both sides, when x equals to minus 3 is going to be one of the solutions. Or, if I plus 2 to both sides, that's going to be when x equals to 2. Just go ahead and substitute 2 into this, so why don't we do that? Just to double check. Let's sub in 2, so 2 plus 3, 2 minus 2. Well, I'm not going to say equal to 0 yet, because I want to check that's true. So this would be 5, and this would be 0. So what is 5 times 0? That is 0. So yes, this is working, and we could have done the same with minus 3, and we'd have got that. Okay, how about this one? So this is when x plus 5 equals 0, or when x plus 4 equals 0. I don't know why I did the brackets, we don't need to. Take away 5 from each side. So when x equals to minus 5. Or we can take away 4 from both sides on this one, and when x equals to minus 4. You might just be spotting on these examples that it is just the opposite sign. So instead of positive 4, the answer's negative 4. And instead of positive 5, the answer's negative 5. And that is that's how it works out with these when it's just 1x on the front. And if we go to plot this, well, we'd have a little dash at minus 5, we'd have a little dash at minus 4, and we just draw a curve that hits them too. We don't know anything about the rest of it, unless we did some extra work, but right now we can say, well, it's going to be something like that. We know it's positive, and we know it goes through them 2 points on the x-axis. Have a go at this one for me, please. So you want to factorize. And then second, you want to solve. That's so you set each bracket equal to 0. So have a go at that one for me, please. Pause it. Okay, hopefully you've had a good go. So when you factorize this, you are going to get x. Well, let's have a look at our factors of 42. It's going to be 1 and 42. I know it's not going to be that. I know it's not going to be the 2 and 21 as well, because we need to make a 1 here. Remember, this is a bit like a ghost 1. It's going to be something like 6 and 7, because them numbers to me, obviously, that we can make 1 out of them. So we got a negative number here, so I know one of them needs to be positive and one of them needs to be negative. That's the only way we can multiply to make a negative number. And I've got a positive one here. So I think my positive number needs to be 7 and my negative number needs to be 6, because if I do 7 take away 6, that leaves me with positive 1. Okay, so that's my factorized. And then I need to say, well, when is each bracket equal to 0? I don't know why I keep doing the bracket on the second one. So in this case we can say x equals to minus 7 or x equals to 6. And if we were to plot this, I'm going to drill this point home because you might need it for later in your maths life. If we plot it, we're going to have a little point at 6, a little point at minus 7, and it's going to kind of arc between these two, like that. There'll be some questions that you're going to have a look at, and I'm not going to flick to the next slide because they are all your answers. There'll be more explanation on what I want you to do with the task in writing. But thank you for watching till the end, and I hope you found that useful. I'll hang on till 15 minutes because it's nice and rounded. Bye.